A remarkable discovery was made by the James Webb Space Telescope. Light beams that appear to come from an urban area but come from a location millions of light years away. Interest in the possibility of extraterrestrial life has been rekindled as a result of this finding. The closest exoplanet to our solar system, Proxima Centauri b, was the focus of the telescope's attention, and strange, brilliant flashes of light were observed there. Could it be that these emissions are from an alien civilization? Keep an eye out for more updates. The concept of life beyond Earth has captivated scientists and the general public for years. There has been a lot of excitement generated by any evidence that points to the existence of life elsewhere in the universe. However, the James Webb Space Telescope's clear evidence that life might exist in space was a groundbreaking development. This powerful observatory made an astonishing discovery while scanning the universe. The possibility that an extraterrestrial metropolis might exist on that far-off exoplanet was sparked when it observed lights on the planet that resembled those of other cities. The scientific community is very excited about this theory because it gives them hope for a breakthrough they've been waiting for a long time. It suggests that intelligent beings and civilizations may have existed in ways that we are only just beginning to comprehend. The city-like lights could be seen from a remarkable 4 light years away. Engineers at NASA were awestruck as they considered how long these signals might have been visible in space while we waited for our technology to advance to the point where it could detect them. The planet where these lights were discovered, according to Columbia University astronomer David Kipping, is unusually complex. Due to its unique relationship with its star, Proxima Centauri, this exoplanet behaves differently than many rocky planets that absorb sunlight and emit energy as infrared radiation. The significance of the James Webb Space Telescope is made clear by this discovery. Its capacity to capture infrared light was crucial in identifying Proxima Centauri b's unusual behavior and revealing the planet's atmospheric conditions. In the hope of determining whether or not the planet is habitable, researchers plan to continue using the telescope to examine the atmosphere in greater depth. Because it is particularly sensitive to infrared wavelengths, the James Webb Space Telescope can observe Proxima Centauri b even at night. Webb excels at picking up even the faintest glimmers in space, where many telescopes struggle to detect faint signals. Because of this, it is an excellent tool for determining whether or not the alleged city lights on the dark side of Proxima Centauri b are real. As long as the artificial light falls within a frequency range that is much smaller than that of typical stars, the telescope can detect it in space. Proxima Centauri b's environment is significantly impacted by its dynamic interaction with its star. It receives a significant amount of energy from Proxima Centauri, as do many other planets that orbit stars. Day and night cycles are experienced by the planet as it revolves around its star. Proxima Centauri b, like Earth, has daytime high temperatures and nighttime low temperatures. Proxima Centauri b's extreme temperature variation is largely attributable to its composition. For instance, if the planet had an atmosphere, there would be a significant temperature difference between day and night, with one side experiencing blistering heat and the other freezing cold. Astronomers should pay close attention to this striking temperature change because it provides crucial information about the planet's atmospheric structure. With its ability to detect infrared radiation, the James Webb Space Telescope can examine the planet's thermal emissions, providing additional information about its atmospheric properties. Strangely, the James Webb Space Telescope's orbit around Earth coincides with the orbital cycle of Proxima Centauri b, making it possible for scientists to closely observe the planet's daylight cycles each 11.2 days on Earth. The next step, assuming Proxima Centauri b has an atmosphere, will be to examine its chemical composition to see if it could support life. The presence of elements like oxygen, methane, and water vapor would suggest that life could exist on the planet. The James Webb Space Telescope is ideal for studying planet atmospheres, but it was not built to do everything. It is particularly good at identifying carbon dioxide, methane, and water vapor. However, it is not as effective at detecting free oxygen, which is an essential sign of life. The telescope can still look for other important indicators like ozone, which shows that the atmosphere is healthy. The search for distant worlds continues as scientists examine the James Webb Space Telescope's data. Humanity is getting closer to finding out whether we are the only ones in the universe with this effort. It's important to note that the James Webb Space Telescope can only look at a small number of distant exoplanets. Astronomers will rely on ground-based observatories like the Extremely Large Telescope, ELT, which will begin operations in 2027 for more in-depth studies of planetary atmospheres. The objective of the ELT is to provide more precise information on the possibility of life on distant exoplanets by taking a closer look at their atmospheric structures. The launch of future space telescopes, like the ELT, is gaining momentum. In the interim, the James Webb Space Telescope continues to be an extremely useful tool for locating distant exoplanets. The Webb telescope continues to provide important data that has the potential to significantly alter our understanding of the universe beyond our solar system, despite its limitations. Future space telescopes are the subject of ambitious plans from researchers. Improved observations of the faint light reflected by exoplanets will be possible thanks to the incorporation of technologies that reduce interference from starlight into these new instruments. These new telescopes will block out bright starlight, making it easier to study the light reflected by distant planets and analyze their atmospheres to determine whether they support life, similar to shielding your eyes from the sun to see more clearly. However, this is not an easy job. Planets' faint reflections of light are difficult to see because stars are so bright and frequently outshine their planets. Innovative methods are being developed by scientists to meet this obstacle. The coronagraph, which is placed inside a telescope to block starlight while allowing planet light to pass through, is one such technique. Coronagraphs can significantly reduce the brightness of stars by carefully shaping the light waves, making it easier to detect planets' faint light. The star shade, a large spacecraft shaped like a flower that will fly in front of a telescope thousands of kilometers away, is another promising method. Only light from exoplanets can reach the instruments because the star shade blocks starlight before it enters the telescope. Observing planets in their star's habitable zone, where liquid water and possibly life exist, may be especially useful with this approach. A high level of precision is required for these advanced technologies. For instance, over vast distances, the alignment of a star shade must be flawless to millimeters or less. In addition, these innovations must overcome the challenges posed by space missions, such as the need for miniaturization, energy efficiency, and the capacity to withstand harsh environments in space. The potential benefits are immense despite these obstacles. Biosignatures, or chemical signs of life, such as oxygen, methane, or water vapor in specific ratios, could be discovered by successfully observing and analyzing the atmospheres of exoplanets. These molecules may indicate biological processes that point to life elsewhere in the universe. Additionally, researchers are looking into ways to directly and more precisely image distant exoplanets. Advanced adaptive optics, which correct distortions caused by the Earth's atmosphere or the telescope's movements and produce sharper images, may be included in future telescopes. These advancements, when combined with techniques for blocking starlight, would make it possible for researchers to not only locate exoplanets, but also map their surfaces and investigate their climates. Our ability to study exoplanets and arrive at well-informed conclusions about their potential to support life would be significantly enhanced by this kind of imaging. Space telescopes of the next generation represent a significant step forward in our search for life beyond Earth. We are getting closer to finding out if life exists elsewhere in the universe by improving our ability to observe distant planets. This could significantly alter our understanding of our place in the cosmos. Space exploration and the search for extraterrestrial life are progressing at a rate never before seen. The James Webb Space Telescope is ushering in a new era of cosmic discovery, allowing astronomers and scientists to delve deeper into the mysteries of distant exoplanets. Astronomers are using the data it collects to learn groundbreaking things about the structure, composition, and possibility of habitability of distant worlds. We get closer to figuring out the answer to the ultimate question with each new piece of information. Is there life elsewhere in the universe? Proxima Centauri. B's discovery is just the beginning of what could be a turning point in our investigation of extraterrestrial life.